we can solve Boyle's, Charles, and Avogadro or Gay-Lussac's law, all using the combined gas law. So if I look at this problem here, I've got a pressure of 1 atmosphere at a temperature of 28. And then the conditions change. I raise the temperature to 56, and I want to find the new pressure. Well, if I start with the combined gas law, PV over T equals P2V2 over T2, they make no mention of the volume here. If they don't talk about the volume, the assumption is the volume is kept constant, and if the volume is constant, it's going to cancel out of there, and I'm left with simply Gay-Lussac's law. So now I have P over T equals P over T. Plug in what I want. My first pressure was 1 atmosphere. My first temperature, remember, has to be in Kelvin. So when you add 273 plus the 28, you end up getting 301 Kelvin. That equals the new pressure, which I don't know, and the new temperature of 56. When you add 273 to that, you end up with 329 Kelvin. Cross multiply and divide, and you end up with 1.1 ATMs. Only 2 significant digits. If we look at the second problem, I've got a pressure of 1.2 atmospheres, a volume of 15, and a temperature. And then I change the pressure to 750, the temperature to 60, and I want the new volume. So, 2 pressures, 2 volumes, 2 temperatures. This sounds like the combined gas law. My original pressure was 1.2 atmospheres. My original volume was 15 milliliters. And my original temperature was 15 degrees Celsius. But you need to add 273, so that becomes 278 Kelvin. Just kidding, 288 Kelvin. That has to equal my new pressure times my new volume, which I don't know, times my new temperature. Well, 60 plus 273 equals 333 Kelvin. Notice the units on my pressures. I've got atmospheres here and millimeters of mercury. Well, they're not going to cancel out if they're not the same. So I need to take my 750 millimeters of mercury and convert that into atmospheres. 760 millimeters of mercury for every 1 atmosphere. When you divide 750 by 760, you end up getting 0.9868 ATMs. And that's what needs to go here, 0.9868 ATMs. So the units atmospheres will cancel, the units Kelvin will cancel. You want to cross multiply and divide, so take your 1.2 times 15 times 333, and then divide it by the 288, and divide it by the 0.9868. Or if you write it out, it kind of looks like this. 1.2 ATM times 15 milliliters times 333 Kelvin should equal 288 Kelvin times 0.9868 atmospheres times V2. And then you want to divide both sides by 288 Kelvin. Kelvin units are gone. These are gone. Divide both sides by 0.9868 atmospheres. These are gone. The units for atmospheres are gone. And we're left with VT on one side equaling 1.2 times 15 times 333 divided by 0.9868 times 288. And you should end up with 21 milliliters. The units for the volume will be the same as the units you have there.